Good morning or good afternoon, depending on when you're listening to this. Or good evening if you're listening to this in the evening for some reason. I don't know, you wanted a bit of light entertainment and learn about some chemistry in your own time. Not judging. And if I was, it would be positively, because you're putting the steps towards bettering your future by probably doing something you don't necessarily want. Alright, bit of an explanation. I'm not with you this morning, afternoon, evening because I'm ill. And I might have to periodically mute myself while I cough. Yeah, so I came down with some interesting symptoms, which may or may not be COVID. Don't know, got a test on Sunday. So I'm awaiting results. I mean, there would be unusual symptoms, but they are potentially symptoms. Basically, all the symptoms of flu that you can get. I've had them all. So that has been difficult, but the lack of sleep has been probably the hardest bit. So I'm making do with the situation that's unfolded, and I'm hopefully going to teach you a little bit about chemistry in the medium of video recording. So help me out a little bit, please. I know it's hard enough to pay attention to me whilst I'm in the class dancing about, let alone when I'm in the corner of a screen and there's probably far more interesting things going on. Okay, bit of an update with the course. So I made a mistake, and this is a good mistake. You know when I said that I'll be teaching you the lab exam? Well, that was a mistake. You don't have a lab exam this year. So, you're welcome. I've just removed an entire exam from your year. I mean, you never had it, but you thought you did, and I've removed it from you. So I'm going to take the credit for that. Yeah, my bad. What I'm actually doing is teaching you one part of your written exam. It's the chemistry part. And they've given this to me because it's the least fun one to teach, I think. And hopefully I'll be able to make it a little more entertaining. But at the end of the day, it's just something you're going to have to learn. So introduce you to it early, and then through repetition, you'll be fine. Okay. So we're going to start off with hydrocarbons. Why are they called hydrocarbons? Well, they're called hydrocarbons. Oh, and please get pens and paper if you'd like to write some of this stuff down. Where's my mouse gone? Oh no, great start. No, like legitimately, where's my mouse gone? Oh, there. It's called hydrocarbons because they're made out of two things. Carbon and hydrogen. Hydrocarbon. Now, a carbon has 4 bonds, so you can attach to 4 things. In a usual condition, this is 4 hydrogens. Nice. You've just got a really small hydrocarbon. The smallest one, because it's only got 1 carbon. You can have a bigger one. Let's say you've got 2 carbons. 2 little C's. Each of them have to be bonded to 4 things. So you draw 4 lines, 4 bonds. That's a big line, my bad. One of this bond is shared. Oh god, this is really messy. I apologise, I can't remember where I've put my little drawing pad. So you'll have to bear with me. And the rest are hydrogens. So each carbon is bonded to 4 other things. still. And then you can add this, and add this, and add this. If you wanted to make it 3 carbons, you'd repeat it. 4 carbons, repeat it. Lovely. Imagine all these are connected with hydrogens. Might be easier if I do it this way. There you go. Oh, look at this incredible paint skills. Okay. They are alkanes. I don't know why they're called alkanes. They just are. And I haven't done the research to find out where the Latin or Greek influences are to why they're called alkanes. Just have to remind. My brain's foggy and apparently my tongue's not working. And my voice is a little fatigued. You just need to remember that they're called alkanes. Okay, so that's the basics of hydrocarbons. That's it. Each carbon is attached to 4 other things. Sometimes that's another carbon. Okay, now there's different ways that you can write this. And you need to know how to write it in 3 different ways. The first way is what I've just drawn on the on the board on paint. Like this, or like this, where you write all the C's and the H's and draw a little diagram. Another way you can write it is by not having the C's and the H's. You just draw a line. This is called a skeletal draw or representation. So for this you've got 4 carbons, so what you do is do 1, 2, 3, 4. So you've got 1 carbon here, 2 carbons here, 3 carbons here, 4 carbons here. So every point counts. You don't need to draw the reds. I was just showing you how you draw that. Imagine you had a hydrocarbon that had, let's say, 16 carbons in there. You try to draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's how you draw hydrocarbons in a skeletal manner. The third way that you need to know is, I can't remember the name of it. Let me double check. You got structural, skeletal, formulaic. I think it might be formulaic, where you just write how many carbons and hydrogens there are. So in this one, it would be C. You put a little 1. You don't have to put a 1. If it's just 1, you don't need to put a 1, but you don't get penalized for putting a 1. And then an H. There's 4 of them. For this one over here, top right, there's 4 carbons. So you put C4, and you count up how many hydrogens there are. 8, 10. Whoops, that's not what I wanted to do. H10. Lovely. It's a cough. Oh, that wasn't a fun one. That was not a fun one. Okay, so those are the alkanes. There's a second one you need to know about. Alkenes. Now, alkenes have a little double bond in them. Now, what's a double bond? Imagine you had a carbon, another carbon, and it really wants to be attached to the other carbon. Instead of just having one bond there, you have 2 bonds there. and you have H's. Now remember, each carbon only wants to be attached to 4 things. So you've got 1, 2 with the hydrogens, then another 2 bonded to the other carbon, and it's the same for that carbon. Any kind of combination imagine all the hydrogens are bonded correctly. Any kind of combination that has a double bond in there somewhere counts as an alkene. So if it's got no double bonds, it's an alkane. If it's got no double bond in there somewhere, it's an alkene. Now, the way you draw this in a skeletal way is for this you do a double bond, or for this you do a double bond like that. We've got 1, 2, 3, 4, 5, 6. Oh dear, I did too many there. And I apologise that this might be a little dry. Unfortunately, you do need to know it. So do try to pay attention if you can. You do need to know it. And if you don't know it, you won't pass your exam. If you don't pass the exam, you fail the year, and then you've wasted all your time here. So it's not a lot that you need to know, and I'm trying to get the drier stuff out of the way earlier. So better learn it earlier to begin with once, than to half learn it 4 or 5 times and then forget. And then in terms of the formulaic approach of writing it, again you just write what you see. So there's 2 carbons there and 4 hydrogens. So there's 3 ways of writing all of these. There's the structural, where you can see the structure of the compound. There's the skeletal, which is just a sort of a quick representation of what's going on, and then the formulaic, which is the number of carbons and the number of hydrogens. Nice. Now, you need to be able to name these. And by name them, I mean increasing amounts of carbons, will have different names. If it's got 1 carbon, it will be called meth. If it's an alkane, you'd put ane at the end. If it's an alkene with a double bond, you put ene at the end. The prefix is meth. If it had 2, and try not to find the fact that I wrote meth on the board hilarious, although it is kind of funny. The next one is eth or eth. If you have 3, it's called prop. If you have for, it's called bute or but. There was a lot of jokes as I made A-level chemistry with that, especially when you get into the slightly trickier compounds. I'll just tell you now, and the immaturity of me and my friends in chemistry class. So there's different types of compounds depending on the how many carbons you have. Depends on what you put at the front of the name. Depending on what type of compound it is, depends on what you put after the name. So if it's an alkane, so it hasn't got any double bonds and there's nothing else going on, put ane. If it's got a double bond, you'd put ene. If it's an alcohol, you'd put anol. Oh wait. Yes, that's right. Anol. However, there's aromatic compounds, I think that they're called, which are anals. So you can see the hilarity that ensued after we learnt that. And we didn't pronounce it butanal. We pronounced it something differently. And we were adamant to pronounce it differently, much to the dismay of our chemistry teacher. And it's still hilarious now. Look, whatever gets you to remember. Exactly. Okay, but we won't talk about those just yet. If you have 5 it starts following shapes. So pent for 5, hex for 6, sept, I think sept, hex for 6, hep for 7, oct for 8, non for 9, dec for 10. I don't know if you know your geometry, but as soon as you get to 5, it follows the shapes, like a pentagon, or a hexagon, or a heptagon, or an octagon, or a nonagon, or a decagon. You should only really need to know up to about 5 or 6. For the purpose of this, just know these 5, and then write down the rest, follow the shapes. Let's move that over here. So, I'd like you to write this down for me. And I'd like you to try to work out what you'd call this compound. Imagine all the hydrogens are attached on the outside. Oh, actually I made a little mistake. I'll give you a couple minutes whilst I cough up my lungs. And I'll also get my head together and work out what I'm going to talk about next. Oh dear, Just move that out of the way. Oh, wonderful. You don't need to know about that complex stuff. Yes. Oh. This year's just got a hell of a lot easier for you guys. And for me. Wonderful. That's what I like to know. So not only did I remove an entire exam for you, you're welcome. Your exam just got easier. Nice. Okay. So, what do you think this was? For those of you who are following the lesson, thank you. What do you reckon it was? To work it out, you first have a look. How many carbons are there? 1, 2, 3, 4, 5. There's 5 of them. Okay, so what do we put at the front? Pent. So, pent at the front. Then you see if it's an alkene or an alkane. An alkene is if it has a double bond in there. There's a double bond there. Okay, wonderful. So you put ene. So surely it's pentene. And you would be largely correct. You would. However, how would you be able to tell the difference between, say, this top one and this, this bottom one? Where the double bond is in a slightly different place. Well, the chemistry people have had a think about that, and they've got around it. Essentially, you count in from the ends how far away the double bond is, which one it's attached to. In this first one, it's attached to the first carbon, and in the second one, it's attached to the second carbon. And even though both are pentene, you need a way of telling the difference between them. So, what you do is you put a little 1. It's 1 before the ene. Oh no, this is not going well. Let's try again. Lovely. It's pent. It's got 5 carbons. It's an alkene because it's got a double bond, and the alkene is attached to the first carbon, or 1 carbon in from the end. And for this bottom one, it would be a 2, not a 1. Nice. Okay. If this double bond was over here instead of over there, it would still be pent 2ene because you're counting from this side now. It's just whichever side is closest to get the lowest number, because you could technically flip this upside down. In a sense, I'll get to flipping things upside down later. Let's worry about keeping things the right way up for now. Oh wait, I just realised you can't read that. Oh, there you go, pent 2ene. You can see it on the right hand side now. Put my face up here for the moment. Okay. Hopefully you've written that down. I'm going to give you another one. Another two, actually. And like you to try to work out what they would be. Imagine I've got hydrogens connected to the end of each of these lines. In fact, I'm going to give you a few. Or four. I'll give you some. See if you can work out what the names of these would be. I'll give you about 5 minutes to work them out. There you go. There's your four. See if you can work out what these are. You probably won't have in the exam the double bonds in awkward places. It'll probably be quite simple. But if I can teach you it's slightly harder than the exam, then the exam will be easier. Obviously. But I think that's a good way to learn, is work something out or just about get confused by something, and that makes the easier stuff more understandable. Oh no, I've just realised that my microphone was muted. That's really annoying. That's really annoying. Okay, I don't know what you heard. I assume it was my last cough. I'll try to, oh goodness sake. Okay, I'll try to run through them again slowly. First of all, you look at how many carbons there are. Each point counts as a carbon on the skeletal formula. So you've got 1, 2, 3, 4, 5. If there's 5 carbons, the start of the name is pent. So you write pent. You then look if there's a double bond or not. All of these are single lines, so no double bond. You then write ane at the end because it's an alkane. There's no double bond, so it's an alkane. Second one. First of all, you count how many carbons there are. 1, 2, 3. 3 carbons start with prop, so you write prop at the front. You then have a look at whether it is an alkane or an alkene, whether it has a double bond or not a double bond. There is no evidence of a double bond here, all one lines, so it's an alkane. So you write ane at the end again. Okay. This third one. You first count how many carbons there are. 1, 2, 3, 4. So you started off with bute or but you run into less trouble if you pronounce it bute. You then see if there is any double bonds or not. Yes, there is. One over there. So you'd write ene because it's an alkene. It has a double bond, so it's an alkene. But you want to tell whereabout this is. So you'd write which carbon it's attached to. In this case, it's the first one. So you'd write a little 1. This last one's a little tricky. It doesn't mean to catch you out. You first count how many carbons there are. 1, 2, 3, 4. So you have a look. It's bute again. So you write bute at the front. See if there's any double bonds. There are double bonds. So you put ene at the end. But where are the double bonds connected to? Got a 1 here. And a 4 there. Attached to the first one. And attached to the fourth one. Or if you did it the other way around, attached to the first one. And then attached to the fourth one. On the other way around. So, you'd probably write something like 1 and 4. Now you will almost certainly not get that in the exam. I'd even put money on you not getting it in the exam. You'd probably only get this one. and you might not even be expected to be able to do the 1. But if you're able to, wonderful. And it's also a good concept to get your head around. Because when we're talking about adding different things, you have to get your head around this number concept. For example, an alcohol is a hydrocarbon. So let's just draw a random one that you're probably familiar. And instead of being attached to so you've got, imagine these are all hydrogens attached to it. Instead of one of them being attached to a hydrogen, it's actually attached to an oxygen and then a hydrogen. The alcohol part of this refers to the fact that it's got this random attachment. Oh, I just realised my face is in the way again. Oh dear. Whoop, here I am. There I go. I can't tell if that's my light flickering or not. It's bugging me out a little bit. Or I'm having a mental breakdown. Probably both. Probably both. So, let me give you an example of this. If you've got a random group attached to it, you change the ending. So, you count how many carbons there are. There's 2, so you put Eth. And if it's got an OH attached to it, it's an alcohol. And then at the end, you put anol. Technically, you would want to write Eth1 anol or ethan 1 ol. Either way works. But because it can only be attached to the first one, because there's 2 of them, if it's attached to this one, it'll be the first one over here. Oh, if it's attached to this one, it'll be the first one over here. If it's attached to this one, it'll be the first one over here. So you wouldn't need to write the 1. Do you recognise this? Hopefully you do. That's the most popular beverage on the planet. Wonderful. If you actually had 3 carbons there, it would become propanol. If you had 4, it would become butanol. You get the picture. Nice. Nice. Don't worry if you're a little lost at the moment. We will be doing this over and over again. You'll grasp it. Don't worry. Don't worry. Let's delete these. Let's talk about bonding strength. You might want to write this down. Which one do you think has a greater bonding strength between it? The one with 1 bond or the one with 2 bonds? It's not a trick question. What do you reckon? Hopefully you answered the one with 2 bonds. If you got 2 fingers linked and tried to break them apart, whereas if you had 2 fingers linked and tried to break them apart, the one with 2 fingers is harder to break apart. Same concept here. Okay, when we're talking about bonds breaking apart, we're talking about energy. A lot of the time in chemistry, that energy comes from heat. So, which one do you think will require more heat energy in order to break them apart? Hopefully you said the second one, because it's got two bonds. Two bonds are harder to break apart than one bond. Things that are hard to break apart require more energy to break apart. If they require more energy, it requires more temperature. Lovely. I'll give you a moment so you can write that down. And so I can cough. So you have to excuse me. I need to drink water. On the topic of temperature, let's make the text slightly bigger. I'm going to write different size molecules, or make them all alkanes for the purpose of it'll be easier to understand. And I'll do 3. Okay. Which one do you think is the lightest, and which one do you think is the heaviest? Hopefully you thought that the one with the more carbon atoms is the heaviest one, and the one with the least amount is the lightest one. Let's put them here. Imagine you had some wind, and I'm going to draw it as blue. That wind was blowing up. Let's draw arrows. The wind was blowing up, and imagine it's distributed evenly over all of them. None of them are moving. None of them are floating away at the moment. So you slowly increase the amount of wind that's being blown on them until one of them starts to move. Which one do you think will be lifted up by the wind first? With consideration of which you thought was the heaviest and lightest just a moment ago. Hopefully you thought the lightest one will be lifted up by the wind first, which would be this one here. Yes, this one gets lifted up by the wind first. Now you increase the wind a bit more. I want transparent selection. There you go. Increase a bit more of the wind. Which one do you think gets lifted up next? Hopefully you thought the next lightest one gets lifted up. And then again, you add some more wind, and eventually the heaviest one can get lifted up. Okay. In chemistry, we don't really use wind, but it's the same sort of principle. Wind is a type of energy, it's a type of force, it lifts the molecules. It works. But it's an easier thing to get your head around than temperature. Imagine, instead of wind energy, we're now using thermal energy or heat energy. So instead of the blue arrows, we're using red arrows. This is a little flame. Wonderful. Let's put these down again. Nothing's moving to begin with. If we add a bit more heat, a bit more energy, which one do you think will be able to break free and become separated from the others? Same principle as the wind. It'll be the lightest one first. Then, as you add more and more heat, the next lightest one will go, and as you add even more heat, you got a proper inferno going, the heaviest one can lift up eventually. So, this is essentially what boiling point is. It's the amount of heat energy, or temperature, thermal energy, that's required for the molecule to separate from its others and float away. And heavier compounds require more energy to lift away from the others. So, with regards to this, which of the following three compounds do you think has the higher boiling point? If the boiling point is how much temperature or energy is required to make the molecule float away from its others. Hopefully, you thought it would be the heaviest compound, and you would be right. As the chains get longer, the chains of carbons, the hydrocarbon chains get longer, their boiling point increases. That's a concept you need to know. Oh, that's interesting. Oh wait, no, never mind. It's just something on my screen that you couldn't see. And I was getting confused. Because my recording software it makes it look like I've got two mouse cursors, and it's throwing me off a little bit. Hopefully. So a little recap. Single bonds are easier to break than double bonds. The longer the hydrocarbon chain is, the more energy it's required to float away from the others, and the higher the boiling point is, essentially. Do you remember last year when I talked about fractional distillation? Maybe, maybe not. Do you remember reflux? Where you've got something like this. Hopefully you do remember reflux, because I went over it a lot with you guys. You've got your liquid here, poorly drawn. You got a little flame underneath. Imagine this brown arrow is a flame. Should have used different colours, but oh well. the blue evaporates. You've got a water jacket on the outside to cool it down. It condenses on the side, the evaporated stuff, and drips back down. Hope you remember that. You might have been in the class where the bung came off it and I splashed it in my face. That was entertaining. Okay. Bear with me 1 second. Let me get a fractional. Okay. So, fractional distillation is the process of putting crude oil, which you've got out of the ground, it's oil that countries go to war over. You pop it into a big old barrel heater thing. You heat it up. As you heat it up, it gets more energy. Nothing happens, nothing happens, nothing happens. You heat it up a bit more, and then suddenly the lightest particles have enough energy to break free, and they float up. And they float up. And you keep heating it, and you keep heating it, and the next lightest one will float up. And then the next one will float up. The further away it gets from the flame and the fire, the cooler it will get. At some point, it will be too cool for it to stay as a gas, and it will condense, much like the reflux. It will condense on the side and drip down. You'll have these little collector pipes that will collect it. Now, the clever scientist people have worked out exactly how tall or how high these collector things need to be in order to collect specific components of the crude oil. So in this one, the top one's petroleum gases. You have kerosene, which is aeroplane fuel, higher than that. Oh wait, no, my mistake. Petroleum is higher. Then gasoline is like petrol. Kerosene, I know this one's not right. This one's not right, but you don't really need to know it. But basically, the heavier compounds like tar and different types of lubricants that are used for industry will be at the bottom because they're the really heavy compounds. And then as you get up, you get the lighter compounds such as petrol, diesel, kerosene. Then you've got other things like ethanol. No, you wouldn't have ethanol. Ethane, that sort of thing will be the higher compounds. You don't really need to know that, but it's a nice sort of, what would I call it? It's a nice link back to the stuff you did last year. Nice. Okay. Whilst I work out exactly what I need to talk to you about now, I will multitask and tell you a little bit about next lesson. So next lesson is only an hour, but it'll be a shorter hour because I appreciate that it's less entertaining me sitting here croaking on a screen than dancing around the classroom, having tangents and chatting and teaching, that kind of thing. So as a sort of little thank you and a little reward, the next lesson is if you can get little worksheets done and you can show them to whoever's covering from me, and it's within a reasonable time. I'd say you can go a little earlier. as long as you negotiate with whoever's covering you. Because at that point, it means you've been paying attention to me over the last hour or hour and a quarter, and you've taken on board what I've taught, and at that point, I can't ask any more, can I? And your efforts should be rewarded. Okay. Let's talk about bond angles. These are pretty simple to understand. If it's just a single bond, the bond angles are straight. If it's a double bond, so this one here, the bond angles are bent slightly. You don't have to draw it, but in actuality, it's more like that. Imagine these ones here are straight. The double bond bends it slightly. The best way I can think of how to visualize that is if you've got two fingers, you can pull it apart quite a lot. Sorry, one finger, you can pull it apart quite easily. If you've got two, the two will want to sort of pull in together, and as they pull in together, your arms will bend with them. Kind of. As it wants to pull in more, because they're stronger bonds, it will bend the molecule. That's all you really need to know about it, is that the angle bends if it's a double bond. Why this is important, we'll go into more detail another lesson. But for the moment, you just need to know that they bend. So the final little bit of this lesson, next 5-10 minutes. I appreciate this. The lesson's supposed to be an hour and a half long, and I think we're just over the hour mark. But if you've been following along, then I'd like to reward that and apologise that I can't be with you today. So as long as you negotiate with whoever's covering for me, I'm sure it'll be okay to let you out a little earlier. However, if you haven't been listening to me and haven't been paying attention, you're going to find the next lesson a lot more difficult. And therefore, you won't be able to leave earlier next lesson, because you'll have to essentially rewatch parts of this video. Or look it up online. So, sucks to be you, I guess, but c'est la vie, that is life. If you don't listen, you can't get the rewards for listening. Okay, what is cracking? Cracking is when you crack apart one of the hydrocarbons. Imagine you had a really long chain. Let's write it out actually. Save myself a little bit of time. Imagine you had a really long chain hydrocarbon and the appropriate hydrogens were attached. And you got this out of the ground because it's part of crude oil. You can't really use this for much. It would be just a dirty, tar, thick, black, nasty substance. You can't do much of it. But for some reason, ethanol is really popular at the moment. I don't know. Something about drinking your sorrows away and sanitizing your hands. There's a big market for ethanol at the moment, but unfortunately the stuff that came out the ground with your little oil drilling enterprise wasn't ethanol. It was this nasty stuff. So, cracking is where you use a series of chemicals or heat to break apart this chain. You do not need to know the mechanics of it, and luckily you don't, because I can't remember the mechanics of it, or not enough and not well enough that I'll be confident in teaching you without having to reteach myself beforehand. But luckily you don't need to. Imagine you had some chemical and thermal process which is able to split this apart, and you split it there. You get that away. That's ethanol. Or no, it's ethane, but then you can convert it into ethanol much more easily. And then you split it again, and you get another ethane, which is much more useful. And then another one. You got another one. Then actually, you know what? You've got enough ethane at the moment. You want to get some methane. Just to pull a prank on your neighbour and make their house smell like farts or something. So you then split it there. You get the one carbon, which becomes methane. Then for whatever reason you want butane. So you want to crack it at 4. And you can crack it at 4. And you've now got butane. Wonderful. Cracking is very useful because it turns essentially non-usable heavy oily components that you get out of the ground into useful components that you want to use. Nice. Okay, next lesson. When you come back from your break, you will have a series of worksheets. I would like you to complete these worksheets. Once you've completed these worksheets, and let's say 45 minutes have also passed, because if you smash through it and rush through it, and then I don't know, you sneakily have one person doing one question, then another person doing another question. I don't know why I'm giving you ideas, and then you all collaborate and then get it done in 15 minutes. Like, even though I respect your ingenuity, although I don't, because I've just put the idea in your head. So please don't do that. Beautiful cover person who's covering me, can you make sure that they don't do that now that I've given them the idea? Get through that individually, and if, let's say, 45 minutes have passed, I say you can go 15 minutes earlier. But you need to show that you have done it by giving it to, or showing it to, the cover teacher. Nice. Thanks, guys. I apologise that I can't be with you today. I appreciate you. I appreciate those who are following along this lesson. I think I know who won't be. And I have the names in my head right now. And I'm imagining your faces. So technically I am looking at you right now. I'm going to call you out, because you know that I know. But please do learn this. Please do learn this. Alright. See you soon. Hopefully.